Hello everyone, myself Dr. K. Purani, Assistant Professor of Mathematics, Arilmigu Palani and Arts College for Women, Palani. In this lecture, we are going to discuss about some definitions in regular singular points. Okay, first definition is what is let us see what is the general form of regular singular points. That is linear equations with regular singular points. P of x into d square y by dx square plus q of x into dy by dx plus r of x into y equal to 0. We put it as equation number 1. The first definition is ordinary points. What is ordinary points? A point x equal to x naught, sorry, a point x equal to x naught is called an ordinary point for the equation p of x d square y by dx square plus q of x into dy by dx plus r of x y equal to 0 if p of x not equal to 0. If p of x not equal to 0 at x equal to x naught means a point x naught x equal to x naught is called an ordinary point. This is the ordinary point definition. Let us see one example. We can easily understand the definition. See, so that the legendary equation, this is the legendary equation 1 minus x squared into y double dash minus 2xy dash plus alpha into alpha plus 1 y equal to 0 at x equal to 0. What is the x naught? 0. At x equal to 0 is an ordinary point. We want to prove that the legendary equation at the point x equal to 0 is an ordinary point. Okay, come to the solution. Given the legendary equation, we write the legendary given equation as legendary equation. In this equation, p of x is 1 minus x square, q of x equal to minus 2x, r of x equal to alpha into alpha plus 1. Here we want to check what is, here we want to check what is, yes, here we want to check p of x not equal to 0. That is the definition. Okay, that is the definition. P of x means not equal to 0 means then that point is called an ordinary point. Okay, let us check here. P of x equal to 1 minus x square at x equal to 0, because question in this question at x equal to 0. So at x equal to 0, p of 0 equal to 1 minus 0, that is equal to, answer is 1. So therefore p of 0 not equal to 0. So therefore at the point x equal to 0, the legendary equation at the point x equal to 0, the legendary equation is an ordinary point. Let's see the another one example. Let's see another next definition. Singular points. What is singular points? A point x equal to x naught is called a singular point for the equation p of x y double dash plus q of x y dash plus r of x y equal to 0 if p of x equal to 0 at x equal to x naught. What's the definition says? A point x equal to x naught is singular point when if p of x equal to 0 means then that the point is called a singular point. Okay, and now see, singular points, there are two types of singular. Okay, what is that? Regular singular, first one is regular singular point and irregular singular point. How to find regular and singular? If we want to find the regular singular point means first, if it is a, it must be a singular point. Okay, if a point, if a point x equal to x naught is a regular singular point means then it must be a singular point. What is a singular point? P of x equal to 0. Okay, a. Also, if it is a irregular singular point at x equal to x naught means then it must be a singular points. If singular points, so finally if singular points exist, then only we can find out regular or irregular singular point. See, let's see the definition of regular and irregular. See, regular singular point. A point x equal to x naught is said to be a regular singular point of the general equation 1. If p of x equal to 0, then only we can find a regular singular point or irregular singular point. So, if a point is a regular singular point means then it must be a singular point. So, if p of x equal to 0, then only we can go to the next step. What is the next step? Limit x tends to x naught, x minus x naught into q of x by p of x equal to finite. The answer becomes finite value. Then limit x tends to x naught, x minus x naught whole square, r of x by p of x equal to, the value becomes finite. Okay, then only it is called regular singular point. Then the next definition, irregular singular point. A point x equal to x naught is said to be a irregular singular point of the general equation 1 if it must be a singular point. Then only come to the next step. What is the next step? Limit x to the x tends to x naught, x minus x naught q of x by p of x equal to, the answer comes in infinite values. The next one is limit x tends to x naught, x minus x naught whole square r of x by p of x equal to, these also the answer becomes infinite value. Then it is in that point x equal to x naught is called irregular singular points. Okay, come to the examples. We can easily understand the definition of regular and irregular singular points. See one example. Okay, see what's the example? Show that the point x equal to 0 and x equal to minus 1 are singular point of, this is the given equation where first one is irregular, where first one is irregular, then second one is regular. Okay, we want to prove that at the point x equal to 0, x is irregular point. Okay, at the point x equal to minus 1, we want to prove that it is a regular singular point. For which equation? This is the general equation. Okay, come to the solution. Let's see. What is the given equation? Okay, this is the given equation. Write the given equation. X square into x plus 1, y double dash plus x square minus 1, y dash plus 2y equal to 0. Here, p of x equal to x square into x plus 1, q of x equal to x square minus 1, r of x equal to 2. Okay, at the first we want to prove, okay, first we want to check that x equal to x naught. Okay, come. First, if we want to prove the it is a regular or irregular, first we want to prove it's a singular point or not. Okay, let's check. P of x equal to this, p of at the point x equal to 0 means p of 0, that is equal to 0. So therefore x is x equal to 0 is a singular point. Okay, now let's, okay, now come to the next step. What is the next step we want to prove? At the point x equal to 0, it is a irregular. Okay, now check. It is an irregular or regular. What's the formula? Limit x tends to x naught. Here x naught is a 0, so limit x tends to 0. X minus x naught, that is 0. X square minus 1. This is the q of x. Okay, this is the q of x by p of x. That is equal to, the answer is infinity, which is an infinite value. If these two, if anyone, and we get an answer infinity means, then this point is a irregular singular point. இந்த ரெண்டு ஃபார்முலால ஏதோ ஒன்றுக்கு இன்ஃபினிட்டின்னு ஆன்சர் வந்தால் போதும், நம்ம என்ன சொல்லிடலாம், அட் த பாயிண்ட் எக்ஸ் ஈக்குவல் டு 0 இஸ் அ irregular singular point நம்ம சொல்லிடலாம். ஓகே, ஸோ we can prove that at the point x equal to 0, which is a irregular singular point. Then now check the next point. What? At x equal to minus 1, it is a singular point and also which is a regular singular point. We want to prove. Let's check. Okay, see, at the point x equal to minus 1, first we want to check it is a regular singular point or not. P of x, here x is minus 1, so p of minus 1 equal to, it becomes 0. Therefore x equal to minus 1 is a singular point. Now come to check the come to check it is a regular or irregular. Okay, what's the formula? Let limit x tends to x naught. Here x naught is a minus 1 into x minus x naught, x plus 1 into q of x by p of x, which is equal to, the answer is 0, which is a finite value. Okay, come to the next step. Limit x tends to minus 1, x minus x naught whole square, which is r of x divided by r of x divided by r of x divided by p of x, which is, the answer becomes 0. So which is also a finite value. So we can prove that, therefore x equal, at the point x equal to minus 1, which is a regular singular point. Okay, okay, hence proved. What we prove that at the point x equal to 0, which is a singular and also it is a irregular singular point. Then at the point x equal to minus 1, see, at the point x equal to minus 1, it is a singular point and also it is a, sorry, 1 minute, and also it is a regular singular point and also it is a regular singular point. I hope you can understand the concept of singular points and regular singular point and irregular singular point. Okay, thank you.